Welcome to this daily LeetCode challenge. In this question, we'll be optimizing a linked list challenge problem. This is an old problem on LeetCode and it's tough to break into the top ranks, but today we'll take that journey to beat over 98%. Given the head of a linked list and a value x, we want to partition it such that all the values less than x are at the beginning of the list. Additionally, we'll need to keep the relative order of the nodes. Let's begin with the linked list. As with many problems, my first goal is just to make a working solution. In this case, it's extremely easy to build two arrays, one with the values lower than x, and the other with values greater than or equal to x. LT is for the values less than x, and GTE is for values greater than or equal to x. Next, we iterate over our linked list and append each value to the appropriate array. Of course, 1 is less than 3, so we append it to the LT array and move to the next item. Then 4 is greater than x, so we append it to the GTE array. And 3 is equal to x, so we append it to the GTE array as well. Then we continue to traverse our list and append the values to our arrays as needed. With our arrays built, we move back to the head of the list and traverse it again. This time we overwrite the value in each node with the value from our LTE and GTE arrays that we traverse simultaneously. We have now partitioned our linked list by overwriting the node values in the proper order. Now we can return our original head pointer as the beginning of our partitioned list. Next, let's take a look at the code used to accomplish this method. The important parts of this solution are that we maintain access to the original head node. That way we can traverse the list a second time and return the original head node as our output. In this section, we created the array for storing the values less than x and a second array for storing the values greater than or equal to x. Finally, we iterated over both arrays and overwrite the values in the original linked list. Note that you don't need to add the arrays together as I have done here. This might be better as two loops. That way you could avoid copying the values. I just like the way this looks better. The time complexity for this solution is O of n, or linear time. Note that we do iterate over n twice. This is still linear time though. Unfortunately, space complexity is where the solution runs into a bit of a problem. Even though the memory performance appears great on LeetCode, I'm not really sure how accurate that is. The space complexity is O of n because we copied each value into the arrays. We can certainly avoid this, so let's make another solution using constant space. For this solution, we'll create two nodes that can be used as the head of our linked list. One for a list with the values less than x, and another for the values greater than or equal to x. This will allow us to just reassign the order of our nodes without requiring creating additional space. We now traverse the list, checking each node to find the partition it belongs to. In this case, 1 is less than x, so we move it to the LT list. 4 is greater than x, so we move it to the GTE list. 3 is equal to x, so it goes onto the GTE list as well. Then we repeat this process for the remaining nodes. Now that we have assigned each node to the proper partition, we connect the end of the LT list to the first value in the GTE list. Finally, we return the first node. Now let's take a look at the code that accomplishes this method. We start this solution by defining the nodes that serve as the head to the LT and GTE lists. Next, we iterate over the linked list and move nodes to the appropriate partition. Finally, we connect the less than list to the greater than or equal list. We terminate the final node with none and return the first node after the LT head. The performance of this solution was pretty good, however it did demonstrate some of the issues with LeetCode's grading system. Here the solution used 16.4 megabytes of memory and beat 14.86% of the solutions. Then running the same code again, the memory usage was the same 16.4 megabytes, but this time it beat 54% of the solutions. Additionally, the runtime performance dropped by 10% for the exact same code. It's not really a big deal, it just demonstrates that you can't put too much faith in these numbers. We can see that the time complexity is still O of n, linear time. However, this solution uses constant space. Technically, this is a better solution than using O of n space, but it still runs slower than the previous solution. This is due to all the pointer assignments we made. To improve this solution, let's consider a list that's already partitioned. Unfortunately, with our current solution, we would still update each pointer. It would be much more efficient if we only updated pointers when we actually needed to change the node that it's connected to. Let's see what that would look like. We have identified that the first item is less than x, so let's keep traversing the list until we find a value greater than or equal to x before updating our pointers. Having found an item greater than or equal to x, we traverse the list again until we find an item less than x, or the list ends. Now we have partitioned our list with only a few pointer updates, whereas the previous solution would have updated every node pointer. Now we can join our list together and return the first node, as with the previous solution. Here's a quick overview of the final solution's code. Sorry about the cluttered view, but this version is amazing. Just look at those glorious results. I take back what I said about LeetCode scoring being inaccurate and terrible. It is perfect in every way. If you found this video helpful, be sure to like it. I'd really appreciate it if you shared it and helped me grow the channel. Thanks for watching. Till next time, keep on coding on.